today I will try my best to do up all the video and upload everything in case you need it. Then where's your WA again? Not so soon, right? 6. Yeah, next week. I promise to do finish by today so that you have the Labor Day, the weekend, and the election holiday day to do up, okay? I promise, okay? So meanwhile, just go and do your own revision first. Okay, so anything you want to ask me regarding WA, like any question after like doing some question outside or whatsoever, you need to ask me anything. Anyone? No, No, Graphs, Would that be what? I think the first, okay, my suggestion is this, yeah, of course. I think the first, no, cannot give you tips, but this is how teachers will usually cycle our students, okay? You all want to hear the tip to do exams? Every single time you see the first question in MCQ, right? Don't do first.
There's always something wrong with this.
No, it's not always something wrong. It's always very difficult, I feel.
The first MCQ.
First MCQ. It's like like in Chinese we call it 下马威. That means we scare you first. Actually, behind is nothing one. You get me? So if you can, don't do first MCQ first. Or even if you do, don't get affected by it. Because a lot of times they say, wow, thank God do that suddenly, wow, you get anxious, mind blank. Wow, die. First question can't even do. The rest of the question die already. That kind of thing. So it gives you this kind of psychology scares. Yeah. A lot of papers, in fact. A lot of papers. So usually, you know what I will normally do? Sometimes I will start doing from structured question first. In fact, the more difficult ones are not the structured question. I feel okay, so if you can, you try to do the structured question first and see whether it helps you a little bit Yeah. Yeah, I am a hardworking student. So I work very hard. So I literally every day do nothing but math. Yeah. Then over the weekends, I will start memorizing my sciences and my humanities. So that is how my study regime is like. I don't study Chinese because my Mandarin is naturally good. So I don't study. Yeah. Then my English sucks, so I don't bother even putting in any effort. I read, okay, but I know I have no hope already. So that's why I put more effort in mathematics, sciences, and humanities.
But you know the graph one where you have to plot the graph?
Yes, I love it.
This, like the WA2 one was evil because they go and make the x-intercepts undefined. So there's no
yes, it's a floating curve, right? Yeah.
And so all of us are like,
is it A math?
E math.
Normally A math, then we'll do this kind of nonsense shit.
But to be honest, I think some people already knew.
Teachers love to give the exceptional cases. So just make sure for how to tackle this particular physics paper is this. Always make sure you get your foundation right. Okay, remember Miss Pan always say in class during moments and things like this, total clockwise equals total anti-clockwise, right? Besides that, what else did I say, girls? Hey, why are you guys looking at your PLD? Like what? Anything? What else did I say? Besides total clockwise and total anti-clockwise, what else did I say? Equilibrium. That's equilibrium. Okay. What else did I mention in that particular chapter? Besides total clockwise equals total anti-clockwise moment, what else did I actually use in that chapter that you remember? Oh God. Total up equals total down, right? Total upward force equals total downward force. Oh, I just said it. Hey, hello. No one cares about me. Okay, total upward force equals total downward force. Okay, what will this lead to? What will this lead to? So if I have total upwards equals total downwards, what will that lead? Yep, equilibrium. So what is the outcome of an equilibrium? We don't call it equilibrium. Equilibrium normally is used for moments. So when total upward force equals total downward force, what would that lead to there? Zero acceleration. Okay? Fr equals 0. Fa equals Ff. Okay? You all must think like this, then everything will be fine. Okay, everybody's here. Now let's continue with this. Okay, so over here we are done with all the different types of energy store in the previous lesson. Okay, so now we look at two different formulas. In fact, three. Okay, there's three. Okay, but we look at two first today. So one is your kinetic store, which is aka your kinetic energy, like the one that you use in primary school. But we don't call it kinetic energy anymore. We call it kinetic store. Energy in the kinetic store. That is the whole phrase. So never ever use kinetic energy, these two words anymore. You have to say energy in the kinetic store. If you want to write short form, it will be capital E and a small k. Why? Because capital E is your energy, the small k is your kinetic. Slide-wise, later on, we will be looking at energy in the gravitational potential store, which is your EP. Any question? Okay, no question. So over here, energy must always be in joules. Okay, mass must always be in kg. This is SI. Speed must always be meter per second. Meters is the SI for length. S is the SI for time. Okay, so now that's it lah. Done. I'm done already. The first part. Okay, so now we practice question. Can we try to get together? So first, the question says that it has a mass of 500 kg. Whenever you see a number like this, always ask yourself, is it in the correct unit? What do you think? Is 500 kg correct unit for mass? Yes, no, dear? Huh? Hey, answer me lah. Is it in the correct unit? Yes, it's a correct unit, dear. It's a correct unit. Is it kg, ma? Do you know where am I coming from? You know my question, right? Okay, so it's a correct unit. Okay, then we leave it alone. Constant speed, 3 meter per second. Is meter per second the correct unit for speed? Yes, okay. What does it mean by constant speed? Yes, okay, but it's not needed here. I'm just testing you for WA, okay? So it's zero acceleration, but this is not needed here. Okay, so why is there a need to be constant speed? Because we wanted to calculate your, energy in the kinetic store. So this V must be constant. It must be uniform throughout. Then we can calculate your energy in the kinetic store. So write down the formula. It is not compulsory to write formulas, but it is always a good practice to have it there so that when you are putting in the values, it will be very easy. Okay, so the working is like this. Is the answer 225? Oh. Anyone? Double check for me, Ken. 9, 12, 9, 18. I think so. Yeah, never mind lah. You guys don't bother. So sad. Okay. Go and calculate and see whether does it make sense to you. Why are you guys so busy? Are you guys following me? Okay, good. Okay, next. Okay, any question? What happened? Why your laptop a bit different? Oh no. Wait a minute. Why the iPad looks like a laptop? Why you want to make your iPad looking like a PLD?
Why was wrong there?
Because the whole point of an iPad is meant to be portable, right? Like it's supposed to be sleek and portable and I don't know. Okay.
But
Where do you put your pens? Oh.
But sure.
Show off.
But I
Hey, this is expensive, no? Yours, this, yeah, freaking expensive.
I didn't know until my parents told me. I got mine for $40.
So nice. I will be like your parent like that. Just buy the cheap one.
No,
Your parents really love you a lot.
I didn't mind anything. Then they're like, okay, so you just want a keyboard. And I'm like, yeah.
Okay, I'll give you a keyboard. Then I'll give you like a $7 keyboard. I never will buy such expensive things. Unless you prove yourself worthy. That means you won't spoil my stuff easily. Then my son always spoil his toy within 24 hours. So that's why I refuse to buy him expensive toy. I always go to like Shopee or Taobao, buy those cheap one. Play. Spoil never, doesn't matter.
You know my cousin, he refuses to play
Oh, that's good.
You play with like plastic bottle with like
Good.
beans inside.
Save money, just like my daughter. Save money. Okay, anyway.
It's like my friend.
Can? Done? Okay, move on. Okay, now, same question asked. Mass 40 grams. Is this the correct unit?
Yeah, no.
No. Straight away convert there. Don't wait already. So you have to divide by 1,000. 0.04 kg. This is exactly what I do in the video also for your WA practice. I also did the same thing. I always ask you like whether is it in the correct unit. This one, this is your kinetic store. Is it correct unit, Joes? Hello. Yes, thank you. Okay, so same thing, move on. Put in the formula. I will always put in formula. This is my practice. During my time, O-level give marks to formulas. So we are all forced to write formulas. Then later on, they change the marking. They stop giving marks to formulas. They give marks to working instead. Yep, so last time we can even play cheat. No, don't know how to do right. Just anyhow bombard a lot of formulas into that question, hoping to get that 1 mark. Okay, but now we cannot lah. Okay, so put in all this. That's why I said in physics, you don't really need to be very good in mathematics, but at least you must know how to do simple algebras, like making the subject of it. Okay, so in this case here, how do I shift? So it's basically 200 times 2. Okay, why? Because I want to get rid of the half. Then divide by 0.04. This is my v squared. Okay, I know I cannot leave my unknown at the back. I know. So I shift it around. This will be 400 over 0.04. Then my v will be square root. Don't forget square root has to be plus minus. This is a good practice. You learn this in math, you apply that in science. Okay? Why? Because of what? Why must we include negative sometimes? It may be velocity there. Okay? But the thing is, we know over here is speed lah. Okay? We just later reject the negative answer can already. Okay? So, I think it's 100 meter per second. Then you can say reject negative. Negative answer. Okay? You can don't write also can. Science, we are not so particular. But in math, you have to write down why you reject, why you accept. Okay? Okay? Can? Okay, last question. Why don't you try? Let me tell you a simple tip from my side, okay? I think I mentioned it to you before. Whenever we are dealing with kinematics, okay, or dynamics, which it involves things like, say, acceleration, distance, or time, or even speed, okay, usually what Miss Pan will do is I will always sketch, okay, a VT graph. Okay, I will usually sketch a VT graph. That is my practice. This is what my physics teacher last time teach me. My physics teacher looks exactly like Mr. Quack, like that say, that vibe. Really, I always believe that a very good physics teacher always have that vibe, and this is the same vibe I get from Mr. Quack also. Then when I first see him, I know he teaches physics already. Really, too bad last time during my time we don't have like camera phone. If not, I would have taken picture with my physics teacher and now I show it to you. Maybe he's still around teaching. Let me check. Last check, he was teaching in St. Mark's. 2 of my physics teachers teach in St. Mark's. My Sec 3 physics teacher left to become St. Mark's HOD. Then my Sec 4, St. Mark's Sec. Then after that, the Sec 4 one, also in the end, go to St. Mark's to be a physics teacher. So St. Mark's grades physics can be quite strong though. St. Mark's.
My friend is St. Mark's
physics
not good.
teacher. Really?
Yeah.
Mr. Ng Song Fu was my Sec 3 physics teacher. He's really good. Then the other one, my physics teacher that looks like Mr. Quack is Mr. Lawrence Tan. St. Margaret. How spell St. Margaret's? Anyhow spell lah. Check GPT. Yo, yes. Is he still in St. Mark's? Tan. There, Mr. Lawrence Tan, is there. But no photo there is his name. He's still there. St. Margaret, Mr. Lawrence Tan. Yeah. But Mr. En Song Fu left, I think.
St. Margaret.
Yeah.
But is it
I'm sorry? Oh yes, definitely. Wait, I was 15 when I got him. So now I'm 41. So 41 minus 15 is how much? 26. 26. I guess by last time he was about 40. So he's about 50 plus 60. Yes. Later on we will search his face. See whether he's...
Mr. Quack's friend.
I maybe should ask him. Yeah. I should ask Mr. Quack, do you know Mr. Lawrence Tan? I should. Later we Google, okay, see whether he's here around. Okay, anyway, can you try question number 3 for me, girls? Try it out. Why don't they show the face of it? Okay? Are you guys done? Yes. Okay, tell me, how do I do it? The question asks for a change in KE. What do you understand by change in something? What must you do? What's the usual step if you have a change? Huh? What do you say? Times or divide. Change in energy though. What does it mean? If I see, I will tell the answer. I pause. Okay, to have a change in something, usually we have to use final minus before. Not necessary, because we don't need to calculate for A, remember. So what I usually will do is I will calculate the KE for the the initial speed, and I'll calculate the kinetic store for the final one. So I have half mv, right? Square. So can I combine? That's the question. I think I can. So what happened is it becomes half 6. 6 don't have to change unit because it's in kg. But for the speed, I will do something like this. Okay, I believe it's the same answer. Okay, so what happened is I will have 2, 4, 6. How do I calculate? Hey, press the calculator for me. Is it correct now? Oh no. Can I do this another way? Wait. Can I calculate this 3 first? What do you get? I know it's 9. Can you do the whole thing for me? 27. 9, 54. Yeah, 27, 27.
3 times 9?
This one, the other one, 25 times 6 times half is what? This is the other one. Can you calculate for me? Half times 6 times 5 square, what is it?
It's 25 times 3, which is 75. Oh, are you so sure? Yeah, I don't know. Okay, 5 times 3 is 75. It's correct, right? 75 times 3 is 78. It's correct. Yeah.
Okay, next one, next one. This one.
I think I found your 102.
Huh?
102.
102?
Minus, oh, I thought it was plus 9. Which one? Which guy? The Lawrence son, right? Is it either one of them? What is his name though? Right. Name though. This is a secondary school. That's so is there another Lawrence son? Sorry, this is this guy. You know how they say those for the family? I thought.
I thought the one is coach and the other one is the other teacher. He's not the teacher. Hey, hi, what is this one there? 48. 48.
Yeah, maybe. Yes, you're right. I think so.
Yeah. The common mistake is this. This is the common mistake, girls. Look. Negative demonstration, This one. You see lah, you press your calculator. 12, right? Can I show you something? I know this is very math because I'm good in math. So I'm going to show it to you. You see whether it makes sense. If it doesn't make sense, just kill me, okay? You see, I show you this. I'm showing you this, girls. Can you take a look? This is quite amazing though, girls. Yeah, they want the board about me. Okay, you see, I'm basically using this. What do you do in mathematics if it's like that? You take a common factor, right? Right? Do you see not? Can you appreciate this? Then what does this mean? This one is your golden rule, right? Remember, this is your golden rule, right? Okay? I'm so sorry, I shouldn't minus like that. I should use like 5 square minus 3 square. Oh, okay. My bad. Can I erase it for you? Wait. Sorry, my bad. Okay, this is 5, this is 3, this is 5, this is 3, this is 5 minus 3, 5 plus 3. Okay, so this is your golden rule. Okay, but what happens if I do it like that? You see this? This is your another golden rule. What will this lead to? A square minus 2ab plus b square. Is it the same? No. This is your a square minus b square equals a plus b, a minus b. This the other one is your a minus b bracket square. You get a square minus 2ab plus b square. They are different there. So you cannot assume that when you calculate like this, it's going to be the same as you minus them. This is wrong. Okay? So you literally have to do like a step 1, step 2, and do a step 3 to get it minus out. Okay, these two are different here. The pink and the red is different. This is the right one. Okay, the right one. That's the wrong one. You see that? It's different. And I'm showing to you right now what is the difference. The difference end up to be different math concept. You see that? Because of the square. If there's no square, of course I can do the red one, no problem. It's the square that affects the answer. Okay? Got it? Can Alright. Can I move on? Are you still copying? Okay? Oh wait.
Is he a student?
Yeah. My form class. Okay, done. Okay, move on. Potential store. Okay. We have a few different types of potential store. We have elastic potential. Okay, we have gravitational potential. Okay, we have chemical potential, we have electrical potential, we have lots of different potential, okay? So the one that we are emphasizing is your gravitational potential store. Okay, so a lot of things are the same, pretty much the same. The mass is kg. The g, if it's near Earth, which is Earth, okay, it's actually 10, right? Then the h must be vertical height. Okay, the h must be a vertical height because it has to lift it up vertically to something, a table, a shelf. I climb the mountain. Everything must go up. Okay, it must be as in vertical. I can come down as well. If I come down from a mountain, I will be changing my gravitational potential store, as in transferring my energy in my gravitational potential store to kinetic store. Okay, you know that? So gravitational potential store increases with increase in height. So if you want this to increase, the height has to increase as well. Okay, if you want your EP to increase, your height must increase accordingly. If your height drops, your EP will drop. Okay? So whenever they ask you change in EP, you can immediately just minus the height in bracket. Why we can't do it just now, just like for the speed, the change in speed, is because it has a square. So this one over here, I could actually rewrite it as, if I want to have a change in EP, I could do something like a mass times G times height 1 minus height 2, can? Like that. I can straight away just minus. But you realize just now energy store, energy in the kinetic store, I cannot do that because of the square. Does it make sense? I repeat, you see, this one is change in gravitational potential store, energy in the gravitational potential store. Instead of calculating mgh, then I calculate mgh again, then I minus. I could actually combine them and minus directly. Why? Because it doesn't have the square. But just now under KE, you realize that I cannot just minus like that because of the square. I have to deal with them separately, like that. You see, I must deal with them separately. I must calculate one speed first for the energy in the kinetic store. I must calculate another speed in the energy in the kinetic store. Then I minus. I cannot lump them together and bracket like that and minus the speed within. I cannot. Okay? But for height, I can, because there's no square for me to take care of. Okay? Okay, with that, let's look at this. Okay, so if I said that the object is 5 kg, first of all, check the unit. Yes, it's 5 kg, it's kg, so it's fine. 20 meters is correct. So substitute everything in. 5, 10 is given. Let me change to another color so it's more obvious. Okay, so 20 is here. So the 10 is quite standard because it's on Earth. So I just minus accordingly. Okay, next. So the same object, lowered. So lowered, same thing. This is my height. Okay, because it's the same object, so the mass is also 5. No change. It is still on Earth, so no change. So when it's lowered, that means to say that my energy in the gravitational potential store is lost. I lost because my height dropped. So when you drop in height, you drop in your energy in your gravitational potential source. Lower, lesser energy. Okay? Higher in your energy in the gravitational potential store. Must remember that. Height is the changing factor. Well, of course, you can say, why G cannot be the changing factor? Can also, if you export the goods to maybe Mars or the moon, then of course, with the change in G, your energy in the gravitational potential store will also change. If you decide to chop away your arm, your head, your leg, then of course mass changes, your energy in your gravitational potential store always change. Okay, but the thing is, assume it's the same object, so it shouldn't change in mass. Anyone a bit confused already? Anyone don't understand? So in physics, in order for us to know whether something changes will affect something, like for example in this case here is E P equals to mgh. So if I were to ask you, if I change the volume of the plasticine, let's say this is a plasticine, the plasticine is in the ball form. So now I ask you, okay, now I make the plasticine longer. Okay, does it change my energy in the gravitational potential store? Let's say I change the volume of the plasticine. Do I change my energy in the gravitational potential store if I change volume? Girls, all look at the screen right now. I'm asking you a logic question. So I say now I change the volume of my object. Volume. Do I change the energy in my gravitational potential store?
Yes. No.
Yes or no? Who say yes? Yes, it changes. Hey, all eyes on the screen, answer my question. All of you must answer the question. Yes, volume will change the energy in the gravitational potential store. Who say yes? Who say no? Why no?
But isn't it only just mass? Only the mass affects.
Three things affects there. Mass affects, gravity affects, height affects. Is that volume? No volume. So no volume don't affect. So this is how we gauge whenever they decided to change the question a little bit, maybe in part B, part C. What happens if I change the volume? What happens if I change the density? Does it change? You get me? So we use that as a gauge to see whether it changes the energy in the gravitational potential store. Just like how you, let's say this is density. Okay, again, back to your WA. Let's say this is density. Okay, so if density we know is mass over volume, right? Right? Okay, so I ask you, what happens if I change I bring this to Mars from Earth? Does it change the density of water? Okay, now the question is density, So now I bring this cup of water to Mars. Does the density of water changes? No. Why? Because in this formula here, there is no G. There's no G. So even if you change from Earth to Mars, G changes, right? But this formula has no G. So G is not the factor to change density. You understand now? So whenever question they ask you this kind of thing, they love to ask if it's electricity. So next time, Sec 4, when Mr. Quack is teaching you electricity, right? They love to ask this kind of nonsense thing. Okay? What happens if I change the diameter or change the circumference of the wire? Does it change? Then you must always check back on the formula. Does circumference, is it found in the formula? If it's not, then it won't change. But there's a deciding factor. So let's say, for example, radius, like pi r square. What's pi r square there? Anyone? Area of circle, right? So let's say if I change the diameter of the circle, does it change pi r square? Yes. Haha. Because diameter Yeah, you divide by 2, you get your R. So you get me? They will fool you like this. They say, but diameter is not R ma, but you can find R. Okay? I'm showing you everything right now. This is very common in electricity topic, which is Sec 4. Last few chaps, okay? Take note of that. So these are some of the things. Okay, back to this. I'm so sorry to digress so much, but I feel that this is a skill set that you have to learn. Because physics has so many formulas, they love to ask, if I change this, does it change that? That kind of thing. So you need to pick up the skill soon. Okay, so it's easier for you to score. Alright. Okay, now I'll continue, okay? Shh. The same mass now move from point A to point B. You realize point A to point B, you are going up a height of 30. Okay? So over here, point A to point B, yes, we don't take into account, we don't take into account 50, okay? Because 50 is not the vertical height. Okay, it's not the vertical height. So we cannot say, oh, A to B, 50 meters. Cannot. We have to look at the vertical height, which is 30. Okay? So that's the reason why we put in 30 over here. Then of course 10 is standard lah, because it's on Earth. Okay? Same thing if the object move from A to B with weird like that. So A is here, B is here. So it starts to move everywhere like that. What will be the gain in EP there? What do you think? What is my height? Yeah, it's still 30 there. I don't care how you go from A to B. I'm only interested in the vertical height. This is a very good question that Mr. Craig put in. Give you different scenario. It's the same thing as what I said last time about displacement. I can travel around the world, but if I go back home, yeah, you're right. Anyone confused up to this point of time? I already showed you 2 different formulas already. One is your energy in the kinetic store. The other one is your energy in the gravitational potential store. So 2 different formulas. I have a third one, okay? When you are done, you let me know. All good, Okay, move on. Okay, wait, let me scroll and see whether is there one more formula. Yeah, work. Okay, I'm telling you there's one more formula at the back, okay? But before I introduce this, they wanted me to introduce this first. Okay? So now no more formula, we talk about the idea of energy conversion. So what they can ask you energy conversion definition, okay, because it's inside your syllabus. Okay, you don't believe me, you go to SEAB, you type SEAB O-level physics, science physics, okay, you will see that you guys have to state the principle of conservation of energy. So what does principle of conservation of energy states? It states that energy cannot be created or destroyed, it can only transfer. Please use the word transfer, don't use the word converted, because converted was what you memorized way before Sec 3. Okay, then you must say from one store to another. And the overall energy in the system, okay, the overall energy in the system remain constant. Okay. I think they use the word net energy, but I don't like to use the word net, so it's up to you. Okay. So we always said this to people, right? Okay. Whatever you lost may be somebody else's gain, right? So this is exactly what it means. So if I gain in energy in the gravitational potential store, I will have to lose something just to gain something. Okay, so I lose what? I lose energy in the kinetic store. Okay, so if I were to lose energy in my gravitational potential store, okay, I will have to gain energy somewhere else, which is the kinetic store. Okay, please pay attention. Don't keep on looking at PLD, looking at other things. Okay, focus, because ultimately you are sitting for the exams. Okay, not me. I already passed with flying colors already. Okay, so always remember, okay, teachers teach not because we want to do very well or whatsoever. We do well in what? Nothing. We already sit for exams already cast in stone already. If I really do very, very well, I'll most probably not sit here already. I'll most probably be a doctor already. Okay. So again, like I said, there are smart teachers out there who could easily just become a doctor, but they choose to be teachers, which I totally salute them. Yeah, do you know among our mates we have really smart teachers?
Like who? One example, who's your age?
Younger than me though.
Who just say?
He's from the Imperial College. You know Imperial College?
The young teacher.
Yeah.
The one with like brown hair.
You know who is Imperial College? You know what's Imperial College?
Yes, the royal.
Yes. Do you know Imperial College? College is better than Cambridge. As in, not Cambridge, sorry. It's better than NUS. So NUS is like number 8 in the whole ranking of the world lah. Imperial College, if I'm not wrong, is top 3, I think. Oh. Oxford, I think. Is it Oxford called Imperial College? Oh yes. You go and think about it. Maybe it's me. Haha. I don't know, okay? But I'm telling you, there are people out there that are really smart, but in the end they choose to be a teacher. Okay, let's move on. So over here, there's a few teachers that are quite smart. Okay. Nah, don't tell you.
Is it just the science teacher?
No, the whole point of me telling you this is that some people really have a passion to teach, and they are willing to forego the monetary gains that's out there just to become a teacher. The teacher, we don't really earn much, you know that, right? Yeah. So when we teach for a cause, okay? So you really have to appreciate your teachers and don't make them mad, okay? Okay, that's all I have to say. Bye. All right, I only left with 5 minutes, okay? Let me show you something, okay, babe? Okay, let me show you how do we apply this particular formula. Okay, hello. Okay, so over here, same thing. You go and ponder, okay? So we have 4 kg of mass, okay, dropped. So when you drop, what happened? When you drop means to say that you are actually reducing the vertical height. So when you reduce vertical height, you are basically transferring energy from the gravitational potential store. You are transferring energy back to become energy in the kinetic store. Okay, so now they're asking you what is the energy in the kinetic store just before it hits the surface. Okay, just before it hits the surface. So first of all, we must calculate how much is lost. Okay, we lost this, we gained this. Take note. Okay, so how much are we losing? So we calculate how much it drops. It drops by 2 meters. Okay, decrease in height. We are dropping height in 2 meters. So my mass, my G, my height, I get this. So this is my loss. Alright, So whatever I lost in EP is whatever I gain in KE. So this is important. Okay, this one. So 80 joules, although it's EP, but now it becomes KE, right? You understand? So EK at B minus EK at A is actually 80. Meaning I take into consideration the drop in height all the way down. I decrease in height. So that will lead to this, where I actually minus, okay, the decrease in height will actually lead to a change, okay, in my EP. So my EP changes by 80 joules. These 80 joules will cause me to increase my KE. This will gain EK. Okay, decrease in height, which cause a drop in EP, will cause me to gain in EK. So in this case here is 80. Always remember, if I drop $2, you pick up my $2, I lost $2, you gain $2. Okay, it's always like that. So you cannot say that EK at B is 0. You cannot say that because it is resting, because we are talking about just before. So the question is very smart. Just before, they say, but just before may not be 2 meter, maybe it's 1.99999 meter left. Sometimes we give and take, okay? We give and take, alright? We don't take into consideration what die must the table that is considered landing. Cannot, okay? So we always say just before, that means it's very near to the ground already. We just take it as it's 2 meters, okay? Just take it. Because the minute it touches table, gone, no more. You understand? It's not the faster. That's the reason why the higher you are, that means I climb up to 50th floor, I drop down, I will die. I will have a higher chance of dying than dropping down from the 3rd floor. Why? Because 3rd floor you don't pick up too much speed. The energy, not great. You realize the higher you go, the higher energy you have. So when you convert to energy in the kinetic store, what happens? What are you exactly converting into? I'm converting into speed. You know that? When you climb up, can you look at me, girls? When you climb up, you are gaining height, which will cause you to have more gravitational potential stored. Okay, energy and gravitational potential. If you drop, what happens? You are gaining energy in the kinetic store. Kinetic energy, obviously, you are gaining. But when you are gaining energy in the kinetic store, what are you actually gaining? I'm gaining my speed. That's the reason why if you drop from 3rd floor, you don't have enough time to pick up the speed. You don't die, maybe you just break one leg. But if you drop down from like 20th floor, you will die. Because you have a lot of energy in the gravitational potential shock for you to convert back to KE. Yeah, so your speed will naturally be faster. So this is how it works. Okay, I'll continue again next lesson.